Hi, y'all. Hello. Welcome. Good to see you all. Welcome to JavaScript, the hard parts. I am Matt. Thanks, Ted, for the wave. Appreciate it. I'm Matt Severin. I'm the lead instructor for the part-time remote immersive program, Petrie, as it's called affectionately. If you didn't hear me bantering with Paolo about it, it's so good to see him. Cool. So what that means is, now that I'm a lead instructor of Petrie, that means I went through the program. Paolo was Petrie 2. I went through Petrie Beta, so we're talking years ago at this point. I graduated, I became a fellow, and then I moved on to an engineering instructor, and now I sort of run the program. That also means I'm on the engineering team for Codesmith. I work on Codesmith.io, CSX, some of the other internal tools. And I work for other companies outside of Codesmith, creating automated workflows, CRUD applications, and on and on and on. I do want to hear from you a little bit. I want to know who I'm working with. So I'm going to go as around the room as I can. I want to be cognizant of time, because we do have some JavaScript material I want to get to. So if I don't get to everybody, that's cool. But I do want to talk to some of you. So if I call on you, if you could please tell me where you're tuning in from, how many hard parts you've been to, and your favorite JavaScript resource, that would be awesome. And Gary, you're in the upper left-hand corner of my screen, so you win. Tell me about yourself, my friend. Where you're tuning in from, how many hard parts you've been to, and your favorite JavaScript resource.
Okay, so I'm tuning in Worth. This is my first hard parts work. And what was the third question? Oh, resource. Well, so far I find Codesmith, the CSX platform, has been really helpful. So I'd say that.
Cool. Yeah, it is. Great information there. As you start finding what feels like gaps in the CSX curriculum or something that's not fully explained, look into things like MDM to round out that knowledge. It's not an accident that we don't give you all the pieces that you need to solve problems. That is the hard learning starting right there. Did you say Fort Worth? You cut out a little bit.
Yeah, Fort Worth.
Okay, cool. Are you a Cowboys fan? Do you follow football at all?
I don't really follow football, and they've been kind of bad recently.
Well, they've been a tease, but good for you. Football doesn't help you do anything in life. Oh, Shannon, are you volunteering?
I can volunteer. I had a question to build on that, but I can also go.
Which you're going to do both, so whichever order you want to do it. Take it away.
Hi, folks. My name is Shannon. I'm in the Bay Area in California. I just did the last couple weekends. I did the JavaScript for Beginners course, which is really great. And also kind of getting to know resources, CSX and MDM. But I was actually curious about CSX because I found myself going through and getting, more often than not, getting frustrated and then kind of getting down on myself that I couldn't figure out, certain problems. And then I was like trying to work on it, and then like an hour or two would go by. So I'm wondering how common that is, and I'm trying not to like give up on myself and like turn away from coding just because I'm frustrated. And B, I keep telling myself that. And like when you get to those points, what are there other resources in that moment that you found are really helpful? Like, do you have go-to ones in those moments that you recommend we check out?
Yeah, great, phenomenal. How many people are experiencing the same thing Shannon is? So many hands. Absolutely.
Thank you for the validation, guys.
What did you say?
I said thank you for the validation.
Yes, absolutely. I'd say it's very common. I went through the same thing when I went through the program. And that is somewhat by design. I talk about the hard learning in Codesmith. For those of you who want to come to the immersive, you can expect more of the same. Shannon, have you ever heard the term imposter syndrome?
Oh, totally.
Yeah, that's what often happens when folks are, especially in engineering, like it rears ugly head in engineering almost more than any other field. Like that voice that's telling you, you can't do this, you're not going to get there. It's just frustrating. You bang your head against the wall, you're never going to get the answer. That's a big old lie. You are gaining so much that you don't even realize you're gaining when you're going through these couple hour-long sessions not solving a problem. The neural pathways you're building as you're trying to tear down a problem and hitting a brick wall and hitting a dead end and reading documentation and not understanding what it's saying and getting so exhausted because you've looked up 4 words in a 5-word sentence. Like, yes, absolutely, that happens all the time. But the amount you are gaining, like the under the hood energy and neural pathways and problem solving brain that you're building there. It's sort of like going to the gym, right? I keep going back to football. I don't know why. Maybe it's because there's a game on and I'm thinking, no, I'm not. But like those athletes go to the gym and they lift a bunch of weights. That doesn't directly help them catch a football, right? They still have to go on the field and practice, but they're building those muscles so they can do that with excellence. When you're banging your head against the wall, sometimes you're not getting any closer to an answer, but you're building the muscles that are going to make you a great engineer, because that's 90% of the job. Having, even if you're an expert, trying to build something is so complex, you're still going to be banging against your wall trying to figure out how to do certain things. And so you're going to have those mental calluses to be able to withstand that. Those mental calluses are going to serve you when you have to learn something that was never taught to you, which happens in engineering all the time. Oh, you're a JavaScript engineer? Great, here's a project in Python, help me do it. And because you go through these processes, you have the ability to teach those things. You start building up your own network of resources to turn to in your own best practices when you hit these blocks. So this is not lost work. Resources that I go to, MDN is a great one. Stack Overflow. Sometimes if you just type in the problem that you're having, it'll flat show up in Stack Overflow. And that's why getting this vocabulary is so important. Writing like can't solve problem, help doesn't get you there. But if you're talking about, I don't know what the second argument, the second part of the signature of a for loop is, typing in like that, and you'll get an answer right away. So just plugging those things into Google are going to get you there. MDN is going to get you there. These workshops are going to help you there. JSB is going to help you get there. All these things together, I think, are going to be tools in your tool belt, and you're just going to pull out, you're going to start to feel which one you want to pull out at certain times. I know it's not like the most like targeted answer, but I promise it has
I appreciate that just what I'm feeling. I'm not alone, right? Because I think the younger version of myself would have just been like, oh, I suck at coding, I'm not meant for it, and then give up, right? So it's encouraging to hear that other people like also are uncomfortable and struggle, but they get there, right? So that's awesome.
Yeah, you could have literally the folks. Gosh, I just kicked off Scratch projects with my mid cohort, so they've been with me now for 4 months. And I could have plugged you right into that group of people who've been working on this for 4 months, just built full stack applications, pretty incredible ones. And you could have said that sentence and they all would have been like, oh yeah, I'm going through that right now. You would have fit right in. Yeah. So it kind of never goes away. But your ability is increasing, even if you don't realize it.
Good to know. Thanks, guys.
Yeah. If it helps too, think about where I don't know how long you've been on this journey. You've been through JSB. Think about the things you knew before JSB and the things you know now. You know more. You're able to do more. And that's all, each and every single day. If you learn one new thing, it was a successful day. And you just have to keep reminding yourself, comparing yourself to when you started or you yesterday. And that's when you start to see how much you're actually growing.
That's a great point. Thank you.
Awesome question, y'all. Well, Shannon, y'all didn't ask it, but awesome sharing. So cool to see. And I'm sorry, where did you say you're from?
I'm from a town called Pinole in the East Bay, so I'm about 30 minutes from San Francisco.
Bay Area, that's right. Yeah. I was just there a couple of weeks ago, and as I was taking off, there was an earthquake.
Huh.
Like a 4-pointer, so like 2 weeks ago, 2-3 weeks ago.
Yeah, I missed it. Interesting. Hopefully you missed the triple-digit wave we had. So but you got.
I came in on the tail end, of that heat wave. Yep. Good stuff. Patricia.
Hello, I am Patricia. I am also from the Bay Area as of yesterday. I was actually born here, but I've lived for 23 years in Minneapolis, Minnesota. And I just moved back to be close to my family. So I'm living at my brother's. My brother spent his whole career as a software engineer. I spent my career doing bookkeeping in a natural food warehouse. And as I was making the plans to move back here, I was like, I just need to get into something different. I need to like try new things. And so I have also I took the JavaScript for beginners, but back in April. So I actually feel, and then I've been like in this crazy packing, moving thing for many months. So I feel definitely kind of rusty. And I'm relating hard to what Shannon was saying. Like I was trying to do a little brush up before this today, and I was like, I remember what these terms, I remember reading these things, but I don't remember how to do these things. And definitely the W3 school resource is one of my favorites. And I've also been having some good luck a couple times Googling things for YouTube like I'll Google something and then I'll find like a YouTube tutorial that'll relate to the thing. So
Yeah. Great stuff. Great stuff. Also, one of my favorite teachers, an online teacher, Mosh, Code with Mosh.
Oh,
Mosh.
yeah.
Yeah,
that's one of the YouTubers I've been watching. Mosh. Cool.
I recommend him as well if you haven't encountered him. Great stuff, Patricia. The good thing is, if it was ever there, it comes back quick, even if it's rusty. I'm always forgetting things. And then like I look at 2 sentences of something in documentation and I remember all of it all of a sudden. So it does come back quick. One of my really great friends is in Minnesota, Minneapolis.
Oh.
Yeah. And has anyone seen the new Netflix series about Jeffrey Dahmer? One person.
Not yet.
A friend is like the poor guy is such a doppelganger for the guy that plays Jeffrey Dahmer. Like, right, we're like, dude, you gotta change your look. Sorry, you gotta change your look. It's not the time. Not the time. That's not relevant to anything. You just said Minnesota, and it made me think of it.
Yeah.
So cool. Well, I'm glad you're getting close to family. That's always a great thing, and I'm glad you're here, shaking off the rest.
Thank you.
Cool. Kevin.
Hey there.
Me?
Yeah.
Yeah.
Okay.
Kevin H.
Go ahead.
Sorry. Yes.
Okay, I'll go first. I'm actually
Both Kevin. Yes,
from...
Kevin without the Hendrix. You go ahead, and then we'll do Kevin Hendrix. Back to back Kevin.
Awesome. I'm actually from San Francisco as well, the Bay Area. This is my third hard parts. And then just, I love MDN. That's really good reference point.
Cool, cool. Glad to have you. A lot of Bay Area folks here tonight. I've never actually been to San Francisco. When I was there, I was in like near Cupertino. I went to the Apple campus. They didn't let me in. Fools. They don't know what they were missing. Cool. Glad to have you. Kevin H.
Hey there. I'm from Knoxville, Tennessee. This is my first hard parts. And I love MDN a lot. Just reading how things work and in specific technical terms is always nice to find you can get some hidden gems out of that that sometimes get glossed over in just tutorials with examples. So yeah, I'd say MDN.
Yeah, I remember when I started, I hated MDN because I never made any sense to me. And then the farther along I got in my journey, the more I loved it because it was so specific. Good stuff. How far is Knoxville from Chattanooga?
It's about an hour and 45 minutes. Yeah.
Okay, so they're going to start building the new Volkswagen ID4s in Chattanooga, the 2023s. And gosh, I almost said I should just know. Yeah, okay. So I'm just going to do it. Y'all, this is kind of a secret, but not really. So my wife is pregnant. We're just getting out of the first trimester. So like we're getting out of the place where we're all worried about it. And so we're looking at cars. We had this little itty bitty Honda Civic and I'm trying to get 94. Well, I did get 94. And I was so mad because 2022 doesn't get the federal tax rebate because it wasn't built in America. And that ended in August. If I would have bought it in August, I'd have been fine. Now only the 2023s are going to have the federal tax rebate because they're going to be built in Chattanooga, Tennessee. But I can't wait that long. I can't wait till 2023 to get a car. So I'm just out $7,500 and I am steamed in case you can't tell. Thank you, y'all. Thank you. Knock on wood. Still, well, we're out of the first trimester, but you know, I'm always like thinking about that stuff. Ugh. It's like someone told me that when you become a parent, your heart is just outside of your body for the rest of your life. And and like I feel that already, and the baby's not even born yet. Ooh, wait, where was Paolo's, where did she go?
I'm right here.
Hey, you can't, if he heard that, he can't tell anybody. It's still kind of a secret. It's not, Petrie doesn't know yet.
Okay.
Okay, cool. I'm gonna wait until much farther along before we tell the community there. Thank you. So, gosh, okay, let me do two more. I'm getting away with murder here, and you all want to talk about JavaScript. So I'm going to keep running down my line here. Unless folks really want to go, they can throw their hands up. I can do two more. So I'll start with Carter.
Hi, I'm Carter. Hi, everybody. I'm from Denver, Boulder, Colorado area. This is my second hard parts. My first was on recursion. My favorite resource has been MDN as well, along with Free Code Camp and CSX.
Yeah, Free Code Camp is a good one too. Lots of great stuff to practice there. Boulder, Colorado. I've only been like in that area once, not even Boulder, it was closer to Denver, but I have no stories there except it was like in the mountains in our hotel. We were at a casino or something. My wife was doing a performance there. And so I just went with her for the weekend. And so the hotel was in the mountains. And so our room was on the top floor. And just to see what would happen, as soon as we got off the elevator, I ran as fast as I could all the way down the hall to see if like the oxygen would make me pass out. It didn't.
Nice. I love it.
Cool. Thanks, Carter. So glad to have you here. Ellie.
I am from Fond du Lac, Wisconsin. This is my first JavaScript hard part. And my favorite resource is also MDN, although I did get my start using Free Code Camp, and it has a very special place in my heart. I still go back to it from time to time. And CSX. I'm really enjoying the platform.
Yeah, cool. Glad to have you. And yes, isn't it funny the way that your first resource like burrows your way into Mosh was my first resource. And so I'm like, oh, Mosh, where would I be without you? I love it. Are you a Packers fan?
No.
We can be friends. I'm originally from Detroit, so I'm not allowed to be friends with anyone who loves Green Bay.
What about Bears?
I don't have a problem with them. We've both been bad for a long time, so
okay,
I can get over it. You're a Bears fan?
Yes.
Yeah, the city of Chicago is beautiful. I love it there. Yeah, I love it. It's beautiful. Nothing like Detroit. Can't even make the comparison. Lovely city. Cool. All right, y'all. Welcome. Are you like ready to do coding yet? Like, shut up, Matt. Talk about JavaScript. Holy crap, it's been 45 minutes. Yeah, okay. So we're gonna get there right now. First of all, everyone who just spoke up, thank you so much for sharing. I know it's really not easy to talk in front of people, especially when you don't know each other. But that is something I would like us all to start getting used to. I'd like you to start expecting that when you come to hard parts. This is going to be a group activity, both in just getting to know each other and working through the problems. That means that I'm, like I said, going to be working with you to technically communicate our way from problem to solution through code. And I know working together, talking out loud to each other, that is going to foster some anxiety within. I know that a great deal of anxiety, believe me, standing up in front of a room of 70 people that I've never met before, talking about such a broad topic as computer science and JavaScript, I feel it too. But what helps me get my anxiety under control when we're talking about these things is something that I would like us to embrace in this room tonight. It's something I tell myself every time I'm leading a room. I think it's vitally important that we achieve some semblance of this here tonight. And that centers around these three words: I don't know. Oftentimes, they bring with them a sense of defeat. I think they're definitely brave words to say in front of a room of strangers. But most people, when they say I don't know, they think I don't know something and I should, therefore I feel inadequate. Instead, I would like us to think of those words as I don't know something and now I have the opportunity to learn it. I don't know is literally the reason all of you are in this room. If you knew everything, you wouldn't need to be here. This would be a waste of your time. So please do not fear those words tonight. If we're working together, if I call on you, I don't know is a perfectly acceptable answer. All of us have it about, you will ask me a question tonight that I will not know the answer to. I'm almost 100% sure. 99.9, someone will do it. That's okay. We are all here to grow. Even better than saying I don't know is trying to use the things that you do know to work your way towards an answer you don't, because that is engineering. Even if you don't end up with the answer that I have in my brain when we're talking about this stuff, that's okay. Watching someone trying to deduce an answer, work their way to an answer, we can learn so much by watching people's cognitive processes getting from point A to point B. Even if we try to hit Z and Q in between, it's still great to know where the logic went a little bit sideways. So please do not fear, I don't want to say guessing out of the blue, but do not fear working your way towards an answer that you don't have. I'm right here to help you. I'm going to make sure we stay on track as much as you trust me to stay on track after I've gone on like 15 different tangents. I promise when it comes to the code, I'm a lot better. But just have that courage tonight. Give yourselves that permission to not know. Give yourselves that permission to work towards these answers, even if you're not sure what they are. Cool? All right, and with that, callbacks and higher order functions. So callbacks and higher order functions seems simple to folks who have been around JavaScript for a while, but it's one of the more misunderstood concepts in JavaScript. And it is so important. It enables things like map, like filter, like reduce, these array methods that you might be playing with at this point in your journey. Asynchronicity. The web is built on asynchronous JavaScript. Asynchronous JavaScript would not exist without callbacks. So this is a cornerstone of the web. It is an important concept and one that not a ton of people are able to articulate. They'll say, hey, that's a callback function, but they don't know why it's a callback function. We're going to unpack some of that here tonight. It also makes your code a lot more declarative. Have we heard those terms before? Declarative versus imperative? Declarative programming essentially means a lot more readable. Imperative programming is a lot more step by step. I'm going to write a for loop that's going to iterate over an array that's going to do, go through all the way through each element in the array until I hit X. And then I'm going to push those, I'm going to take those elements and put them into a function. And then the results of that function, I'm going to push to an array. And then I'm going to return that array. Or that's imperative code. Or I can say array.map, which does the same thing. That's the declarative version of all that same stuff. Does that make some sort of semblance of sense there? Declarative is a lot more readable, even though you don't know all the steps that are going on in between. So callback functions, higher order functions, make your code a lot more declarative. And it's a big piece of the Codesmith technical interview, which might be why most of you are here. Cool. We're going to talk through a lot of JavaScript tonight. In order for us to walk through functions, there are some principles we have to get under our belts. Number one, functions. I keep throwing that word around. What is a function? A function allows us to store logic, like a recipe for executing, for producing some result. If you could pull the page out of your recipe book and just run it every time you wanted cupcakes, that's what a function allows us to do, but in programming. It's a way for us to store logic, store a set of steps that we can just run over and over and over again. Functions help us stick to an important principle in programming known as dry. D-R-Y. Does anyone know what that means? I saw Carter's meat hand come up first. Feel free to use your virtual hands. I'll try to catch it. If you throw up your meat hand, I'll try to catch it, but no promises. Take it away, Carter.
Sure. Yeah. It just means don't repeat yourself.
Don't repeat yourself. Absolutely. Functions allow us to store a logic. So rather than rewriting those steps every time I want to get that result, I can just rerun the function. Dry. Do not repeat yourself. Then we have this thread of execution. So JavaScript is single threaded. It runs left to right, top to bottom. Single threaded means it can only do one thing at a time. So the thread of execution is a conceptual device that allows us to track where we are in the execution of our code. We'll sort of take on the role of the thread of execution tonight as we're stepping through code. Typically, it's the JavaScript engine that's running the thread and tracking your code and everything. But tonight, we're gonna take on that mantle and walk through code. And then we have the concept of memory. So we have functions, storing logic, the thread of execution, tracking where we are in code, and then memory, a place to put stuff that we want to use later, a way to sort of persist data, right? If I didn't have memory, I wouldn't be able to recall anything. All I could do is just use what's right in front of me. Memory allows me to store things away that I might need later. Sometimes you'll hear it referred to as a context, or a variable environment, or a lexical variable environment. You can think of an execution context as the conceptual space where we're going to run our code, where we're going to execute code, where we're going to track the thread of execution. In that execution context, we will quite literally have the context for running our function, which means a memory to store things like variables and constants, that space for where we're going to actually run through the code in our thread of execution. As it works its way through functions. So all of these things together, maybe not, yeah, all these things together kind of make up an execution context. This will allow you to persist, store data. In case you can't tell, you can come to expect this terrible penmanship with me. I haven't even written words yet, and this is already a mess. Just do your best. I'll try my best to at least make it so you can indicate what something was, but by and large, you'll have to remember and listen to what I'm saying. Okay, now I need a volunteer though, because to introduce you to these concepts, so they're not just concepts, but you actually have some experience with them, we're gonna walk through this bit of code and I need a volunteer. Austin was ready to go. I dig it. All right, Austin, there are 3 things I need to run any bit of JavaScript knowledge or logic. Do you know what those 3 things are?
Run any bit of JavaScript knowledge.
Logic. Don't listen to me misspeak. I need to, if I want to run JavaScript code, I need 3 things. Do you know what they are?
Memory.
Yep.
And execution.
In what specific, you're absolutely right, memory is one of them. What specific memory might I be referring to here?
Global memory.
Global memory, on fire, absolutely. We need global memory, a place to store stuff. What else do I need?
Global execution context.
Global execution context, absolutely.
And then a call stack.
And then a call stack. 100%. It sounds like you've done this before. That's not a knock. That's great. Yes. Global memory, a place to store stuff in our global execution context. That global execution context, we're actually going to track the thread of execution and which lines of code we're interacting with. And then the call stack, which tracks which execution context in which we're operating. So take it away. You've got the 3 big ones. What am I doing? Let me give you some lines of code here.
Okay, so we will start by using keyword let to declare a variable labeled num and assign that the value of 3.
Where am I going to do that?
Then that's going to go to global memory.
Absolutely. Spoiler alert there. Keep going.
And then we are going to declare a function labeled multiply by 2 in global memory, and then assign it the value of its function definition.
Okay, so I'm going to declare a label in global memory and assign its value, the function definition. I've got that. What's next?
And we are going to skip down to line 7 and declare a constant labeled output and assign it the evaluated results of invoking multiply by 2 and passing in num.
Oh my
variable
goodness.
num.
Oh my goodness. Did you all hear that communication? That was so crisp. That is exactly what we are doing here. Quick question. We skipped down to line 7. Why did we do that?
Because we haven't invoked the function yet, so we don't go into its definition or coding block.
Absolutely, 100% right. And then I love declaring a constant different from a variable. We can't change this one, and its value is going to be equal to the evaluated result of invoking multiply by 2, passing in num, the variable num as argument. So what's its value going to be? There's going to be a time delay here, even if it's only a tenth of a millisecond or something. What's the value going to be while I'm waiting to get this evaluated result?
Undefined.
Boom, nailed it. Nailed it. I wish you were in the immersive right now. I'd be giving you so many math bucks, but alas, I only give those away to folks in the immersive. Okay, so we're invoking a function. We need to do a bunch of stuff. Austin, what do I need to do here?
So we are going to push multiply by 2 onto the call stack first. Yeah.
I dig it.
And then we're going to open a local execution context.
Cool, we are, but I'm going to make sure we annoy ourselves a great deal when we do this each and every single time tonight. So, like I said, hard parts is a group activity. So we are never going to open an execution context alone. Whenever it's time to open a new execution context, whoever's doing it is going to lead us in. They're going to say, and now we're going to open a new, and everyone's going to unmute, and together, loudly, obnoxiously, we're going to say execution context. And if you don't do it that way, you're going to break my heart and I will cry. So, Austin, you have to lead us in. It's a big responsibility. It's the first time we're doing it tonight. And let's see how much energy these folks have. Let's see how much participation they have.
So we're going to open a new
Execution context.
Oh, that was a stellar first go, you all. I am impressed. I think that's the best first go I've ever had. You warmed my heart. Sorry, and my cat is playing fetch now. She brought in her little ball and she wants me to throw it. And I threw it and she brought it back. Okay, take it away, Austin. Oh, I gotta do the thing. You're like, Matt, open the context. Cool. So we now have a local memory and we are running multiply by 2.
And then we are going to, in local memory, input number is going to be assigned to num, which is 3.
Cool. So yes, our thread of execution enters our local execution context. We encounter our first line of code, which is, well, essentially this right here, right? So we're going to match our parameters in our arguments, right? So you're absolutely right. The value of num is going to be the value of input number. So where am I going to find the value of num?
In our global memory.
In global memory, what is that value?
3.
And where am I going to save this parameter, input number?
In local memory.
In local memory. So we have input number. And we're assigning the value of num, which is 3. Does that make sense to everybody? Sweet. Okay, take it away, Austin. What's next?
And then we have a constant result, which is going to equal the evaluation of input number times 2, which I guess we do in the local execution context. Do we evaluate that there, or does that just go to local memory?
Great question. Let's start with the constant. You said we're declaring this constant. Where am I declaring this, and where am I going to save it?
So we're going to declare it in local memory.
Yes. So I'm going to declare that constant result. And what is its value? Yes, we need to do this operation. So the first thing I'm going to do is JavaScript is going to encounter a word it doesn't know. It's not a reserved keyword. It's not for. It's not return. It's not function. It's not a word that it knows. So it's going to go, huh, what the crap is this, right? What is input number? And where's it going to look for input number?
In local memory.
Yeah, and actually, specifically, you're right. In this case, local memory, specifically, generally, JavaScript will always look in the closest memory that it has. So right now, we are in this execution context. The closest memory to this execution context is local memory. So it's going to look there. Does it find input number in local memory?
Yes, it's 3.
It does. It's 3. So cool. Now it has a value for this. Then JavaScript is going to encounter the multiplication symbol, and it's going to say, what am I multiplying it by? 2. JavaScript will evaluate this entire line before it actually does anything. So you're right in that this will probably be 6 before we actually save it all in the memory. I don't know the exact order there, but JavaScript will look at the entire context of the line before it actually does stuff. Conceptually, for our intents and purposes, yes, we're going to evaluate this in our local execution context.
Okay, cool. And then we are going to return that result outside of the local execution context.
Cool. So I see the return keyword. That means I want to spit out something out of my function. What am I going to return? I'm going to look for a result. I'm going to find it in local memory, and I'm going to get that value 6. And where do I return it out into?
It's going to be assigned to output in global memory.
To output in global memory. Fantastic. What's next?
And then we pop multiply by 2 off the call stack.
I love it.
And then we garbage collect our local execution context.
Cool. Yeah, the thread of execution will re-enter the global execution context once we pop this off. And then I'll say, you're wrong. You're not wrong. This does get garbage collected. The way I tend to say it, though, is that this now becomes eligible for garbage collection because we don't actually have any control over that process. JavaScript is going to do that in the background whenever the heck it feels like it.
Okay.
Great. What's next? You're on fire.
Now we will then declare a constant called new output and assign it the evaluated result of invoking multiply by 2 and passing in 10 as its input.
Cool. So where am I going to declare new output?
In global memory.
In global memory. New output, and what's the value going to be while I'm waiting for this result?
Undefined.
Undefined. Fantastic. And then, okay, we're doing some things. What's going on here? What happens now?
We are then going to push multiply by 2 with input of 10 onto our call stack. And then we are going to open up a new local
execution context. Oh, was that Ned? Ned was on it. Austin tried to like sneak one by us, and then was like, no, no, sir, no. Absolutely.
I realized halfway through local, I was like, oh.
Yes, yes. Just be happy we're not doing recursion. Oh my goodness, does it get annoying in recursion? Local memory and multiply by 2. Sweet. What are we doing now?
Then we are going to read line by line, left to right. It's going to hit input number, and that's going to go into local memory and be assigned 10.
Cool. So yes, 10. We are going to match our parameters and our arguments. So where am I getting this value 10?
It's the argument, or it's what's being passed through multiply by 2.
Yeah, between the parens, whenever we invoke a function, whatever is between those parens is the argument. This parameter is going to be a placeholder for that incoming argument. Collectively, all the arguments or all the parameters are known as a function's signature. Great stuff. What's next?
Now we are going to declare a constant result in local memory and then assign it the value the value of the evaluated result of input number, which is 10 here times 2, which is then 20.
Right. Yes. Awesome stuff. What's next?
And then we will return that result outside of our local execution context.
Cool. So I'm going to return. I'm going to say result. What the crap is that? I'm going to look in my closest memory. I'm going to find the result. I'm going to say that value is 20, and I'm going to return that out of the function. And where does it end up again? Did you say it? I might have missed it.
It's going to be assigned to new output in global memory.
New output. Absolutely. Because the next execution context where we're returning this out of is global. That's how I know to look at global memory. All right. What's next?
We're going to pop multiply by 2 the function off of the call stack, and then our thread of execution is going to return to the global execution context, and then that local execution context will be eligible for garbage collection.
Look at that, picking up terminology on the fly. Absolutely. All right, what's next?
We are done.
We are done, he says, he asks. Are we done? What do we think? Yes, we are done, Austin. Fantastic job, deft communication, amazing work. All right.
Thank you.
Yeah, great stuff. Those are the concepts: global memory, global execution context, call stack. These are the things we need to get started, and then executing code line by line, saving functions and invoking functions, different things, all done beautifully. Okay. All of that together allows us to write and run code. Functional programming, buzzword here, is a paradigm. It's a method for writing code. There are conventions and rules that we follow for a variety of reasons when we're trying to decide how to write code. Functional programming is a methodology that encompasses a lot of those rules. Object-oriented programming is another methodology for writing code. One of the concepts associated with functional programming, pure functions. Pure functions. That means no side effects. When I first started learning this, I'm like, great, what's a side effect? Like I took a pill and now my foot is 3 times bigger than it's supposed to be. What does it mean? What that means is nothing outside the function is affected by anything inside the function. The function doesn't reference anything outside of itself. It's completely contained. It has no effects outside of itself whenever you run it. Pure functions have no side effects. It takes in an input and it produces an output without affecting anything else, which means that it will always, given the same input, it will always, always, always produce the same output. It's not relying on a network request. It's not relying on a piece of logic that exists outside of itself. Nothing impacts the environment inside. So whatever, if you give it the same input, it will always produce the same output. Higher order functions are another lovely concept provided to us by functional programming. Map, filter, reduce, these array methods I mentioned earlier, they are higher order functions. Why? Why? Because they are. We'll get to that. We'll get to why here in a little bit. They're going to make our code more readable, and there's not much else to say about that. Just give your future self some love by writing readable code. As soon as you can, start adopting a declarative programming style, and I promise future you is going to be very, very happy. Jin, do you have a question?
Yes. Can you give me an example about the side effects? I'm still have a hard time understanding what that means.
Sure. So if I wrote a function, say multiply by 2, right? Say I'm running a function multiply by 2, and in the function logic for multiply by 2, I call another function, multiply by 3. This is relying on logic that exists outside of the function. Does that make sense?
Yes.
In web development, you're mostly going to see it in terms of network requests. Like inside my function, I'm actually making a server call.
Yes.
And so now the result depends on whenever that server call returns. So if my server call fails, my function can fail through no fault of my own.
Oh, okay. Now I get it. Okay, got it. Okay, yeah, that makes sense. Okay, perfect. Thank you so much.
Great question. Great question. And if it makes sense now, but doesn't make sense later, feel free to ask that question again or ask for more clarification. Absolutely. It's a challenging concept if you're not familiar with full stack architecture. Shannon.
How common or uncommon kind of proportionally are pure functions to higher order functions? Is higher order like 90% of what you'll see in pure functions is like 10%? Is it pretty split?
It's situational. It'll depend on what you're trying to write. There are functional programming aficionados out there that are like, you have to write everything in functional programming. Functional programming is the only way to write things. And so they are constantly striving for pure functions. Obviously, you need to make network requests, so that's impossible to exist solely on pure functions. But then there's the OOP folks who are like, object-oriented programming is the only way to write programs. It's the only way that makes sense. So like the farther along you get in your journey, you're going to develop your own opinions and like to write things the way that you like to write things. When it comes to higher order functions, you can have higher order functions that are pure. You can have higher order functions that are not pure. It's all about how you want to write them. Higher order functions came about because people were trying to achieve pure functions. Was that a bunch of gobbledygook? Did that make any sense at all?
I was thinking of like two groups in a bar arguing over which is better on how to write things. It was great.
Welcome to software engineering. That absolutely happens.
That's
100%.
a real thing, huh? Okay, awesome.
You're in the Bay Area, right? Go to any bar like around any of those big companies, and I'm sure you'll hear people arguing about this technology or that technology. It'll happen.
That's great.
Yeah. That's also why you can Google one thing and come up with 30 different answers and 30 different approaches for the same thing, which is incredibly frustrating early on. Cool. So let's start unpacking all of this stuff. Like we have functions, pure functions, saving logic. Why do we do any of this? What's the point of a function? How does it make our code dry? Well, let's find out. Should I call on someone? I'll ask for a volunteer. I need a volunteer to help me feel some pain. We're going to explore the reason why we have functions here in programming. Why are they a concept? I need a volunteer. Who wants to help me write a function?
Me.
Ellie, I love
I
it.
can't find my raised hand thing. So
You threw up the me hand and the me voice. I dig it. Okay, so you're going to help me write a function. It's going to, we want to do what the slide says. So what am I going to write? Help me do it.
Okay. You have to bear with me. My technical speech is almost non-existent right now.
I love right now. It's on its way. It's improving. It's in process.
Yes. So we are going to declare a function.
Cool. So what do I want to write? If this is my code, if this is my screen, what do I want to write here? I am your keyboard. Tell me what you want me to spit out.
So put, oh crap.
You already said it. I'm just being anal retentive.
I'm having a total brain fart right now. I'm trying to remember if I need to put anything before the word function.
Well, just do what you think, and then we'll find out if you're right or wrong.
Function.
So you want me to write the word function?
And then what do we want to name?
What do we want to name? That's a great question.
We'll do 10, but 10 written out, TEN, lowercase, and then squared, but with an uppercase S.
Oh my goodness, you are so precise and so correct. It's remarkable. Yes. Camel casing it, y'all. This is so good. And the time she took to think about how to name things, so important, especially as you're writing bigger applications. Naming things is really hard, but it is so important to help your code have some semblance of readability. It's actually a high-level skill. Awesome stuff. What's next? What do you want to see me write?
We're going to do a parenthesis. Sorry, open and close. Oh wait, no, because we're writing it out, so we don't need the close one just yet.
No, you're right. You're right. You do want this.
And then the curly brace.
Oh my goodness. Technical communication on point. Okay, what's next?
No input returns. So I would say return 10 times 10, but I feel like that would be too easy and I'm missing something.
Let's find out. Does this meet the requirements of what is on the slide here? What do we think? Yes, it meets the requirements. I'm satisfied. I'm not going to say one way or the other because I'm going to equivocate. No, throw her off the bus. Everyone is in agreement. You nailed it, Ellie.
Really?
Yeah, you nailed it. You killed it. 100%. 100%. Absolutely. Yes, this is all we were asked to do. Create a function 10 squared, and you nailed it with such technical precision that I'm like in just writing words. You're even talking about how you want to case the name. Great stuff. Absolutely. This is exactly how you do this. Round of applause for Ellie. Thank you so much. All right. Next up, I need another volunteer. Patricia, we're going to write another function. This time we want to square 9. How am I going to do this?
Okay, so here again takes no input. So you're going to write function and then a space, and then as Ellie said, and thank you, Ellie, you did awesome. So lowercase NINE, and then capital S and the word squared, and then open and close parentheses, and then open curly brace, and then on the next line, return 9 times 9, semicolon.
Oh my goodness, y'all.
And then on the next line, close curly brace.
Yes, absolutely. Even the clean code, she doesn't need ESLint, y'all. She's going to add her semicolons on her own. A great practice.
I have question. Why? I mean, would anyone ever write a function this simple? Like, why would you need a function if the function only does one exact precise thing?
Someone might be getting ahead of ourselves.
Okay.
Hold on to that thought. Hold on to it. While you're holding on to that thought, I need help again because I'm just real bad at this, y'all. I need a volunteer. Who wants to help me out? Nobody? I'm going to pick someone. Ari.
Sure. Okay. So let's do it. So I'm going to type function. And then I'm going to write 8 squared, 8 typed out, S capital, open and close parentheses, curly brace, and then in the new line, return 8 times 8, semicolon, and then another curly brace.
Just take my word for it. That was everything you said. What you see here is everything you said. Cool. So is this it? Do we agree? Does this work? Everyone agrees. Is there a problem here? Are we sensing, Patricia, I think Patricia's sensing a problem. Anyone else sensing a problem with the way that we're writing our code? I'm seeing some nods. I'm seeing some hands up. Cool. What principle are we violating here?
Dry.
Dry. Yes. Sorry, Ryan, you got usurped. Yes, the dry principle. Do not, or don't, not deny, don't repeat yourself. Don't repeat yourself. Yes, we're violating that principle. Did you all hear that? I have 2 cats, and they're mad that I'm not in bed right now. So yes, these are doing the exact same thing. We are repeating ourselves. It's the same logic over and over and over again. Whatever number we have, we are just multiplying it by itself. Patricia, are these functions useful?
They feel not very useful.
You're trying to be so kind. We can do each of these functions. No, they're not useful. It's just as easy for me to write this, or this, or this, right? It's just easy for me to write those things. These are not useful functions. So, Patricia, you're off the hook. How can I fix this? How can I fix this? How can I make this better? Ryan.
We could write a new function called function and just call it num squared and pass the function a parameter called num. And then have that function return num times, multiplied by num. And then when we pass an argument to that function, it will return the argument squared.
What do we think, y'all? Yeah, Ryan, excellent job. Even though you forgot the semicolon, I guess I can still pass you. No, excellent job, absolutely. So what we can do is generalize the function. I'm running the same logic here in all of these three. So to fix it, I just generalize it. Now this takes in any number and it multiplies that number by itself. So now we have a parameter. We can give that parameter a value. That label will be multiplied by itself. Now I can reuse, the big point is I can reuse this logic wherever I want to. I don't have to rewrite it each and every single time. I can just pass this in and it will automatically return the result for me. So I'm not rewriting this. I'm not using these same 3 lines of code over and over and over again. I'm writing these 3 lines of code once, and then with 1 line of code, I'm executing that same logic. This is the purpose of functions. We all felt the pain of what life would be like without functions. We'd have to write that out each and every single time. This is what functions allow us to do. Shannon, question.
Yeah, this might build on what you were saying earlier about there can be multiple ways to get the same result. Could you do return num squared or num raised to the power of 2? Would that be the same? Yeah.
Something like that, yeah.
Yeah.
Yeah, or there's also like a math function, like exponent times. There's a number of ways to do things.
Okay, so you'd still get the same.
Yep. And people have opinions on that too. You wrote that way. I wrote it this way. It does the same thing. Doesn't matter. And sometimes it even makes your code less efficient. If you're really playing around with things, give you the same result. But if you have a nested for loop or you're using this function instead of doing it manually, so there are ramifications here. In this case, this super simple example, not that big a deal, but it is something to be cognizant of. That's why this is so hard. Software engineering is as much an art as it is a science, because this stuff does matter at advanced levels. But great questions, y'all. Great questions. Y'all are really on point. You made me think like you were a bunch of very new folks, but you're knocking everything out of the park and asking great questions. So it's lovely to hear. Stephanie.
Since you mentioned it, I know it's not like completely related to what we're talking about today, but I know there's that segment on recursion, and I remember reading a lot of people saying that you should avoid recursion when possible because of the memory sort of demands that it makes. So is there, like in sort of professional programming nowadays, like is there certain situations where you do, like you should use recursion?
There are a ton of situations where you should use recursion, and I'll say you should avoid naive recursion. Not all recursion is bad. Naively written recursion is what's complicated. And if you're curious about the hows and whys of that, hang out afterwards and we can chat about it.
Okay, great, thank you.
Yeah, great question. Any others? All right, cool. So we generalized a function here. Let's start building our way towards higher order functions. We've got the pieces in place for how this is going to work. Now let's start looking at the value that it brings to our code. And that journey starts right here with this function. Bianca, I'm going to ask you a question. She's like, oh no, please don't. Maybe she's not. I don't know.
Go for it.
Just looking at this function, the name of this function, before we even start diagramming it out, what do you think this function is going to do?
It's going to copy the array and multiply each element by 2.
Oh my goodness. Remember that time I said naming things is really important when Ellie was doing a great job thinking about how she wanted to name things? This is why. Without looking at any of this logic, right away, I know what I'm trying to achieve here, and that is gold for professional engineering. When you're a professional engineer, your time is money to companies. So if I spend 5 minutes trying to figure out what this is doing, that's 5 wasted minutes, as opposed to 30 seconds reading this title and knowing what it's doing already. That is time saved, that is money saved, that is 5 minutes working on a new feature that's gonna make the next Jeff Bezos. So keep that in mind when you're naming things. There really is an art to this stuff. Great names make for readable code, make for professional code. And that's not just function names, that's variable names too. I was looking at a solution today and someone had named a variable this in a solution. And I said, I know you're referring to money there, but that is a terrible variable name. You should not name something that. Especially because if you're in something like jQuery, that has a very different meaning. Cool. All right. So now I need a volunteer. I won't make Bianca do it unless she wants to volunteer, but we're gonna diagram this bad boy out.
I can start out and then someone can jump in.
Or you can just do it all. You're up, Bianca, take it away.
Jesus Christ. Okay, never mind. So first we're going to declare a function labeled copy array multiplied by 2 in the global memory and
Okay.
assign a function definition.
Copy array and multiply. I'm just gonna shorthand it.
Sure.
To save your eyes. And give it a function definition. Great, what's next?
We're going to declare a constant myArray and assign it to the array 1, 2, 3 in global memory.
Cool.
And then we'll declare a constant result and assign it the evaluated result of invoking copy array and multiply by 2 with the argument myArray.
Oh my goodness, that was quite the sentence, right, y'all? Right, y'all? Amazingly well done. What's the value going to be while I'm waiting for that evaluated result?
Undefined.
Undefined, sweet. So talk me through it. What's happening next?
Then we'll push copy array and multiply by 2 with the argument myArray to the call stack and open a local execution context.
Ooh. Gotta help us out there. Can't do that on your own. You gotta lead us in.
Open a local
execution context.
Oh, that was beautiful, especially because you're so reluctant.
Yeah.
Notice the team met your reluctance with passion.
That was great. Thank you, everyone. And then we'll pass the thread of execution into the local execution context.
Cool. What's next?
Then we'll pair our argument myArray with the parameter array and assign it and assign the value of myArray to array and store it in local memory.
Cool. So the value of myArray is going to be stored under a new label array in local memory. Do I have you correct?
Yes.
Cool.
And then
I'm sorry, I'm debating whether or not I want to talk about primitive and reference types. I'm not going to. I don't want to muddy the waters. If you have questions about primitive and reference types, hang out afterwards and ask me that question. Okay, what's next?
Then we will, what is it? Now we're going to declare a constant output and assign it an empty array in local memory.
Cool. Everyone tracking that now we're inside this execution context, so now we're evaluating the function code. Cool. All right.
Oh, sorry.
Go ahead. You're on fire. Go ahead.
And then we'll initiate a for loop by opening another local execution context or not.
Great question. Great question. Not really. It's block scoped, so it sort of does have its own world, right? I can't access I out here, but I can access I inside the curly brackets. I've looked and I've looked and I've looked for how this works under the hood, and I've come up with nada. Just so all I know is that it's block scoped. It has a little execution context, but it's not truly a function. So where is it saving the value of I really don't know.
So it's still inside the same local execution.
Yeah. For our purposes, that's how we'll treat it. But you're right in that it does have its own scope.
Okay. So I guess we'll initiate a for loop and initialize I and assign it the value 0. And then we will, enter the for loop, and then I don't know how to verbalize this part. We'll push the array at index I times 2 to output.
Yes, that's a great way to verbalize that.
I forgot the condition. We're supposed to check to see if we met the condition I is less than the length of the array.
Cool. And is it?
Yes.
What is the length of the array?
3.
3. How do you know that?
Because array is 1, 2, 3, and there's only 3 spots.
There's 3 elements in the array. Yes, this property on the array class will give you the total number of elements in the array. Absolutely. Is a for loop new to anybody? Do we all understand for loops? It's okay if you don't. Sweet. Okay. And Bianca, you are absolutely right. Everything you said is correct. I did just want to write this stuff out. You didn't skip anything. If this were an immersive, would have been like, you're on fire. Go ahead, girl. All right. So keep going. You are right in that we are going to take the array at element I, multiply it by 2, and then pass that in as the value to output.push. But I do want to unpack it just a little bit. So I'm going to write our array, right? I'm just going to, for ease sake, that's not a word. I'm just going to put it here nice and big so we can all see it. And I'm also going to target, let it be known that we have some indices here. Now, everybody knows that arrays are 0 indexed. Great. So what elements, Bianca, are we accessing when we hit line 4 here?
We access element at index 0, so 1.
Okay. And what are we doing with it?
We're multiplying it by 2, which is 2. And we're pushing it to output at the same index. Or it doesn't matter. It's the first spot.
Yes, so we're going to get that result, and then we're going to push that to our output array, which is here in local memory. Does that make sense to everybody? Any questions on that? All right, take it away. What's next?
Then we will increment I to 1, and then we will check to see if we meet the condition and I is still less than 3. So we enter the for loop again. So we would push the value. Oh, sorry. We will access the array at index 1, which is 2, multiply it by 2, and push that value to the output array.
Great. Awesome. What's next?
Then we increment I again to 2, and then we check to see if it meets the conditions. It does. So we will access the array at index 2, which is 3, and we will multiply that by 2, which is 4, and push that to the output array.
One more time?
I'm sorry? Oh.
One more time?
Wait, what am I? Oh, I don't know how to multiply. Sorry. Access index, the array at index 2, which is 3, multiply it by 2, which is 6, and push that to the output array.
You're in good company. I can't math either. It's multiplying the index and not the value. But yes, absolutely, 100% right. Cool. What's next?
Then we increment I to 3, and it no longer meets the condition. So we exit the for loop, and we return output to result, and store that in result in the global memory.
All right. What's next?
Then we pop copy array and multiply by 2 off the call stack, and we pass the thread of execution out of the local memory, and now the local execution context is eligible for garbage collection. Is that the terminology?
Yeah, you say it like you don't know, but you do. You're absolutely right. Cool. What's next?
Then we're done.
We're done. Amazing work. Bianca, you acted like you didn't want to do this because you were unsure. Yeah, you knocked it out of the park. Such wonderful communication tonight. Just a point of order, when we are invoking output.push here, it does get pushed onto the call stack, but because we don't have access to that source code, it's a fool's errand to try and diagram it out. But amazing stuff. Any questions on what Bianca just did? Cool, cool. So what if now I wanted to copy an array and divide by 2? Does this seem similar at all to anybody? Some nods, some nods. I'm not sure you're all convinced, so let's feel this pain. I need a volunteer. Everybody throws their hands up at once. Was that a hand? Was it, how do I pronounce your name? Nyok?
Yes, and it's knock.
Knock. Cool.
Knock, knock on the door.
Awesome. I love it. Well, take it away.
Okay, so within the global memory, you're gonna declare a function label is copy array and divide it by 2 and assign it to a function definition.
Love it. What's next?
And then since we are not invoking this function, so we're gonna skip to, I think that is line 8, where you're
9.
gonna declare a 9. Okay, 9, where you're gonna declare a constant with label myArray and assign it to an array with numeric value 1, 2, 3.
Cool. What's
And
next?
after that, you're gonna declare a constant label name result and assign it to the evaluated value of the invocation of the function copy array and divided by 2, passing in the input myArray.
And what's the value going to be right now while I wait for that evaluated result?
Pardon?
What's the,
Well, so because we are in.
What's the value of result while I'm waiting for the evaluated result of copy array and divide by 2? So I don't have the, I need to run this logic before I get this. So
yes,
JavaScript.
You need to run it.
Yeah, but
So
JavaScript
while
needs
you're pushing, you're gonna push that function, the copy array to the callback. Is that what you're saying?
Yeah, you're right. I'm going to do that with my array here, but this is going to take some time for me to evaluate this result. And so JavaScript needs to put a value here while it waits for this evaluated result. My question is, what is this value, this placeholder value that's going to sit here?
I don't know.
What'd you say?
I say undefined.
You said exactly the right thing. 100% undefined.
Oh.
The computer doesn't know. So yes, it's going to put that value there, undefined, which is a primitive falsy type. Absolutely. Undefined. I love it. I love being like, I don't know. Let me try to deduce my way to the answer. That's exactly it. Absolutely. Okay. What's next?
Well, then we're gonna open a new
Execution context. I just gotta say, not great work there. You let us in beautifully. If it weren't for Ned, I think we'd have fallen off a cliff there. So y'all gotta step it up. Ned's running away with the game. Sweet. Let's make a little bigger local memory. All right. What's next?
So then in the local memory, you're gonna declare a constant and output and assign it to an empty array.
Almost. One step we're missing. What's the first thing I want to do?
Oh,
I open a new context.
You need to pair the parameter and the argument.
Cool. So what's happening?
You're gonna pair the parameter array to the argument myArray, which is an array with value 1, 2, 3.
Absolutely. So what JavaScript is going to do is it's going to say, great, I've opened this execution context. I have a placeholder here. What value is this placeholder going to have? Let me look at what my function was invoked with, my array. What the crap is that? That's not a reserved keyword. I'm going to look in my nearest memory because we're in the global execution context at this point. My nearest memory, my array, there's a value there. Great. I'm going to grab that array and plug it in local memory with that address. Awesome stuff. No, keep going.
Okay, then next we're going to declare a constant and output and assign it to an empty array.
Okay.
Okay, and now we're going to initiate a for loop. So first we initialize I equal to 0. Since the array length is 3, 0 is less than 3, so we continue to go inside the for loop. So within the for loop, we're gonna push the result of array index I divided by 2. The array index 0 is 1 divided by 2 is 0.5. So we're going to push 0.5 to the output array.
Cool, I dig it. Everyone followed the work? Sweet. What's next?
Then we're going to increase I by 1. So now I equal to 1. And 1 is still less than 3, so we're going to continue the for loop. So now we're going to push the array index 1 divided by 2. So index 1, array index 1 is 2 divided by 2 is equal 1. So we're going to push 1 into the output array.
Cool, I dig it. What's next?
Then continue, we increase I by 1 again. So now I equal to 2. 2 is still less than 3, so we continue with the for loop. So now at index 2, array at index 2 is 3, so 3 divided by 2 is 1.5. So we're going to push 1.5 into the output array.
What's next?
And now we're going to increase I one more time, so I now equal to 3. Since 3 is not less than 3, so now our for loop is done. We're done with the for loop. So now we're gonna proceed to line 6, where we're gonna return the output to the global memory and gonna match it to the result variable in the global memory.
What's next?
And because we're done with the function, so now this function copy array and divide by 2 is eligible for garbage collection. And we also pop this function out the call stack.
Cool. You're absolutely right, 100%. I'll just say that we pop copy array and divide by 2 off the call stack. Our thread of execution exits the local execution context, and then that local execution context becomes eligible for garbage collection. It all kind of happens at the same time, but my brain just orders it that way because it makes the most sense. Nothing you did was wrong there. That's just Matt's superimposed order if any of you want to adopt it. Great stuff. Okay, what's next?
We done?
Yeah, Ned's like, why do you always ask that question? And I was like, are we done? Yes, absolutely. You knocked it out of the park. Congratulations. I got a bunch of some ringers in here tonight. You all are practiced hands. Wonderful communication here every step of the way. Everything I'm nudging you in the direction of is so nitpicky. How many folks are intimidated by how great the technical communication has been tonight? Cool. All of you with your hands up, you should volunteer to go next, because these folks all started somewhere. And trust me, it's not a worry. It's not a worry. That's what I'm here for. Right now, you all make my job so easy. Great. Okay, cool. So we've copied array and multiplied by 2. We've copied array and divided by 2. I think we're finding a groove. How about we add 3? I need a volunteer. I need a volunteer to walk through this again. Do I have one? These functions look the same. Ryan's like, oh, really? Like, look at Ryan's face, everybody. Can you see it? He's like, no, really? You're going to make us do this again? Why are we feeling this pain, right? Because the functions look the same. In fact, there's only one piece of the code that's different every time we run this, and that is right here, the argument to push. All of this other logic is exactly the same. Have we encountered this problem before? Remember when all of these functions were the exact same? We ran the same logic over and over and over again. How did we fix that? We generalized the function. We generalized the function. Can we do something similar here? Can I generalize this set of instructions so that I'm not breaking this rule? This do not repeat yourself rule. How can I make this better? How can I solve this and help ourselves? Well, yes, we can generalize our functions. The only thing different about our logic was whatever we wanted to put in here. So if I wanted to put in a different set of steps, a different way to manipulate my array elements each and every single time, I could generalize that. I could generalize that with a set of instructions, a function, that then all I have to do is invoke. So just in case I wasn't clear, Amanda, what am I going to pass in? This is a parameter. We always match our parameters in our arguments. What am I going to need to pass in here as an argument to make this go?
Function. In this case, the function is multiply by 2.
You're nailing the code. Absolutely, yes. In this case, multiply by 2, but in any case, I could pass in anything. If I wanted to turn all of these array elements into strings, I could do that with a different function. Whatever set of instructions I want to pass in here are going to be used to manipulate my array elements, and I'm going to produce a new array full of those manipulated elements. That's the goal. If anyone's confused, don't worry. We are going to walk through this. So can I get a volunteer? Amanda, I was hoping it would be you because you're like on the hot seat. Why get off it when you're already killing it? Take it away. What am I going to do? Are you talking? All right, because you might have been muted and I wasn't looking.
Okay, gonna declare a function called copy array and manipulate that takes the 2 parameters array and instructions, and that's gonna be saved in the global memory.
As a what?
As the function definition.
Nailed it. Cool. What's next?
And then you are going to declare a function multiply by 2. And function definition is saved in 2 multiplied by 2 in the global memory.
I dig it.
And then you are going to declare a constant result in the global memory, which is the return value of copy array and manipulate with the arguments an array and multiply 2.
Okay, yes. What is the value result going to be while we're waiting for this return value of copy array manipulate?
Undefined.
Undefined. Cool. So Amanda's exactly right. So now we're going to invoke copy array manipulate, passing in the arguments of an array 1, 2, 3, and a set of instructions. So what JavaScript is going to do, it's going to obviously save this constant in local global memory in this case. It's going to know, it's going to read copy array manipulate. It's going to go, what the crap is this? Oh, it's a function definition. Great. What's the next character that I'm going to read? It's a parentheses, which means I'm invoking this function. Cool. So whatever comes in here is going to be a set of arguments. The first one is going to be an array. Great. The second one, multiply by 2. What the crap is this? I'm going to go to my nearest memory. I'm going to find it, and I find a function definition. And then afterwards, I see a closing paren, so nothing. So I am just going to pass this in to my new context. What's next, Amanda?
So you're going to open up a new
execution context. Oh man, like the conductor that she is, the maestro waving us in, expertly done. Okay, absolutely. Be quiet, Matt, and open the context. All right, what's next?
And then copy array and manipulate also gets put onto the call stack.
I love it, love it. Cool, what's next?
And then we're going to match the arguments to our parameters. So array is going to be an array 1, 2, 3. And instructions is going to be the function definition of multiply by 2.
So the function definition, I just got dissed by Notability. There we go. Cool. Everybody following what's happening there? Any questions on what's happening there? Cool. I copied this function. Just know that's not exactly what's happening. I did it to make things a little easier for us to understand. This is actually the exact same function definition. It's not a copy. I just now have 2 labels pointing at the same function definition. If you're curious about how that works, hang out afterwards and you can ask me. Take it away, Amanda. What is going on?
We're declaring a constant by the name of output, which is equal to an empty array.
Does this feel familiar at all? Besides the part where I throw my pencil on the ground and discuss? Cool, right? We've encountered this logic before. Go ahead. What's next?
And then we're going to enter a for loop. So we're going to initialize I to 0. And then we're going to check if it's less than the length of our array. And since 0 is in fact less than 3, we're going to continue into the body. And so we are going to push the result of invoking instructions with the argument of array at the index I. So in this case, that's 1. And so we're going to put 2 because of the result of multiply by 2. I'm going to push 2 into output.
You're absolutely right. But let's break it down, go a little slower, feel a little more pain here. Yes, you picked the winner. We are going to do this each and every single time. So JavaScript is going to encounter this line, output.push. It's going to encounter instructions. What's JavaScript going to do?
It's going to look for instructions.
And where's it going to look?
In the local memory.
Does it find it?
Yes.
Cool. Right. Pardon my my handwriting and my abbreviation. Yes, it does find it. What is the value there of instructions in local memory?
It's return input times 2.
It's a function definition, right? So what's the next character? So we have instructions. It's a function definition. What's the next character JavaScript sees?
Parenthesis.
The paren. And what does that mean JavaScript has to do?
Look inside the parentheses.
Well, whenever we have a function definition followed by open and closing paren,
oh, we're invoking the function.
We have to invoke it, which means we're going to do what?
Oh, we're going to open up a new
execution contest.
Absolutely. So we're going to, in what function definition are we actually running here?
The multiply by 2.
Yeah, multiply by 2, that set of instructions. So I'm actually going to write it as multiply by 2 when it gets pushed onto the call stack over here. So now we're getting deep here, y'all. We have a couple of things going on. So here's my multiply by 2 context down here. Okay, now what happens next?
Okay, so
let me start here. Where's our thread of execution?
It's inside the multiply by 2 function.
Yeah, you can always tell the thread of execution is working on the top stack frame. So yeah, well, maybe you can't tell because of my atrocious handwriting. But if I could write like a human being, you'd be able to tell this was multiplied by 2. That's where our thread of execution is. So what's step 1 whenever we open up a new execution context?
So it's gonna match the parameters to the arguments.
Cool. And so do that. What are we going to end up with?
1 as our input.
Right. Does everyone follow how we got there? The argument is array at index I is 0, so our value is 1, and we are pushing that, matching that with our input. And now what's next?
We're going to multiply by 2, return 2.
Cool. So yes, I'm going to return input. What's input? I'm going to look in my nearest memory. My nearest memory says input is 1. I'm going to multiply that by 2. I'm going to return that value out. And where do I return that value?
You're going to push it to output.
Eventually, yes, I'm going to return it out into this execution context. So a few things we need to do now. Multiply by 2 is going to get popped off the call stack. Our thread of execution re-enters copy, array, manipulate. Multiply by 2 becomes eligible for garbage collection. And now we have a returned result, an evaluated result in here, which we weren't ever even really saving to memory. Now we have an argument for output.push, which is 2. And because we don't have the source code, we're not going to dive into it, but know that it does end up on the call stack. So 2 ends up here. Question, sorry, Amanda, take it away. What's next?
We're going to increment I by 1. So I is going to be 1. And then on the next line, we're going to open up a new.
Almost. What do we do after we increment I by
1? We check and see if it's less than our array length.
Cool. Is it?
Yes.
Yes. Awesome. Cool. Now, you're just so advanced. You want to like jump ahead to all this fun stuff, making you go step by step painfully. Cool. So you're right. What's next now?
Now we open up a new execution context.
Execution context.
Was that Ned? Appreciated. I only heard 2 people do it, so until the room does it, I can't go on.
Execution context.
Oh my goodness, the sloppier the better. And that whoever that was at the end, it's like, oh, execution context. You're my favorite. You're absolutely my favorite. Cool. So yes, we're going to open up that new execution context. And what am I pushing on the call stack, Amanda?
Multiply by 2.
Absolutely. Cool. And what are we going to do now? Step 1 in here.
We assign our arguments to our parameters. So input is going to be 2.
2, right? I at index, or sorry, array at index 1 is 2. So that's going to be our value.
And then we're going to return 2 times 2, just 4.
Cool. So a bunch of stuff's going to happen now. We are returning the value of 4 out of this. What are we going to do in the meantime?
It's going to be pushed into the output array, and then multiply by 2 is going to be popped off of the call stack.
You all saw that, right? I was moving it and then it jumped right back. Notability hates me. Yes, this gets popped off the call stack. Boop, 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 gone. What's next?
And then it's eligible for garbage collection.
It is eligible for garbage collection along with all of my commas. All right, what's next?
And then we increment I by 1. So I is now 2. And then we check to see if I is less than the length of our array, which it is. And then we go and we open up a new
Execution context.
Carter, I appreciate you doing your best. Yes, absolutely. I'll choose the right shade of purple this time. Sorry, Amanda, if I stole your thunder there and put something on the call stack without you telling me to. You can beat me up later.
It's okay.
Cool. Okay, what's next?
So we match our arguments to our parameters. So input is now going to be 3. And then we're going to return 3 times 2, which is 6. 6 is going to be pushed into our output array. And then multiplied by 2 gets popped off the call stack. And the execution context is eligible for garbage collection.
Fantastic. Our thread is back in copy, array, manipulate. What's next?
And then we increment I by 1. I is now 3, which is not less than the length of our array. So we exit the for loop and we return output to our variable result in the global memory.
Gotta preserve the mess that I made. Absolutely. Cool. What's next?
That's it.
Almost. A couple of things I want to do first.
Oh, I guess copy, array, manipulate gets popped off the call, and its execution context is eligible for garbage collection.
Oh my goodness. What's next? Oops.
Now that's it.
Now that's it. Absolutely. We have beaten the final boss, Bowser, spitting fire, throwing hammers. We threw him in the lava. We're at Princess Peach. We defeated the final boss, you all. Amazing stuff. Amanda, excellent work. Everybody else, amazing execution contexts. Any questions on anything you just saw? That might have been a Mario reference. I neither confirm nor deny. Yes, absolutely. So we were able to generalize that small set of instructions. Big question though, how do we do that? How were we able to pass in this function definition in as an argument, right? How does that happen? Well, in JavaScript, functions are objects. They are first-class objects, which really just means you can do to them what you would any other object in JavaScript, which means you can assign it to variables. You can pass it in as an argument. You can return it out of a function. Anything you can do with an object, you can do with a function. Functions in JavaScript are first-class objects, which means I can bundle it up and ship it all over my code as I see fit. Jin.
Since we're talking about side effects, won't that be a side effect since it's coming from outside?
I never said this was a pure function. Remember, we're talking about higher order functions. Higher order functions. Yes. Multiply by 2, definitely a pure function. Copy, array, manipulate, debatable. We could talk about this. Because this is a pure function, can I rely on this to be a pure function as well? Pure within pure. I don't know. It just depends. It depends on what you pass in for instructions, what it does. Great eye. Great call out there. Cool. So now that it came up.
Thank you.
Yeah. No, you're right. Now that it came up, though, we've been talking about callback functions. We've been talking about higher order functions. Which is which? Which is which here? Any volunteers? Jin just had your hand up. Which one is my higher order function? Which one's my callback?
The higher order function will be copy, array, and manipulate. And then I want to say the callback multiplied by 2.
Jin sounds incredibly confident in that answer. How do we feel? Do we agree? On the fence, disagree? Most everybody agrees, and I do too. Absolutely. The higher order function is a function that takes in a function. A callback is a function that gets passed in to another function and essentially gets called back, right? Any function I pass in to another function, that's going to be a callback. A higher order function is any function that takes in another function, and that's it. The concept really is that simple. It's a piece of vocabulary. A function that takes in another function is a higher order function. A function that's passed into another function is a callback function. Easy peasy. So there's really nothing else to say there. For any of you who are super eagle-eyed out there and are really parsing this logic, you might know this as another name. Array.map. Think about what array.map does. You give it a function, it puts all the elements of your array through that function and returns an output array of those modified elements. That's the logic here. This would be the imperative version of array.map. This is the declarative version of array.map. So map, that method, is a higher order function. Whatever function you pass into map, into the argument, array.map instructions, this is the callback. And there's not much more to it than that. This concept is powerful. A lot of people use it. Not a lot of people really understand what it is, why it's there, and how it works. It makes for declarative code, readable code, that professional code. You're going to use it in the Codesmith interview quite a bit. And it is the backbone of asynchronous JavaScript. Without this concept that we explored here tonight, the web would not function. It's imperative for asynchronous JavaScript. And knowing this concept is a great thing, whether you want to come to Codesmith or whether you just want to dink around in your basement making all kinds of amazing stuff. Any way you slice it, this is a good thing to know. And now you all do. All right, y'all. Thank you so much for your time. Abe, you look like a supervillain right now, and I dig it. Have a great night. If you have any other questions, I'm on the CSX Slack. You can reach out there. If any of you are interested in coming to Petrie, I hope you are. I would love to work with all of you. So please, well, actually, what I'd love is for you all to reach your goals. So whatever those goals are, if we can do anything to help you get there, please let us know. Thank you so much, everyone. Have a lovely night.